Okay, so starting with chapter 7, we're going to be talking about ions. So ion will be a new vocab word, and an ion is a charged particle. So it's going to be an atom that has gained electrons or lost electrons to try and be stable or try and be like a noble gas. So similar to argon or helium or one of your noble gases. Essential questions are at the end. Make sure you look at these before the test. And vocab, not very many. But cation and anion will be very important. So, here's where we're starting at. Valence electrons are the most important part when it comes to bonding. So, if sodium and chlorine make sodium chloride, they're bonded together. And it's these valence electrons that are the most important. So any chemical bond is the force that holds two or more atoms together. There's ionic bonds that we're going to talk about. There's covalent bonds, there's metallic bonds. But all of those are a chemical bond. It holds two or more atoms together. Chemical bonds form by the attraction between positive nucleus of one atom, negative electrons of another atom, and these atoms want to form the octet rule, which means they want to get to 8 or they want to be full. And once they are full, they're stable and then they become non-reactive. So if I look at neon, 2, 4, 6, 8, it's full, it's a noble gas, it's not going to bond, and it's not going to react with anything. Other ones, so lithium is not full, it's either going to have to gain electrons or lose electrons to get to 8. And 4 is kind of that magic number. So 1, 2, 3, these are going to lose electrons. 5, 6, 7, they're going to gain electrons. And anything in group 14 or the carbon group can gain 4 or lose 4 depending on what element it is bonding with. Table, I'm going to skip that for now. You guys can do that on your own. So first vocab word, cation, positively charged. Star it, circle it, you need to know that. Cations are mostly going to be your metals because metals are typically what are going to lose electrons. So if I look at the diagram over here, it's using sodium as an example. Sodium's a metal. So it has 11 protons and 11 electrons, makes it neutral. Its energy level is 498, or its ionization is 498. What happens is sodium is going to form an ion so that its valence electrons get to 8, so it is going to lose that one valence electron. So if I do an electron dot diagram, sodium has one valence electron, it's in group 1. It's going to lose that electron, which now means it has 10 electrons. It still has 11 protons, so it's going to have an overall charge of +1 because it has lost an electron. If I go down to potassium, same group, it has one valence electron. It's going to lose that electron. It's also going to have a +1 charge. A +1 charge is a cation. So if I wanted to write that out, I would write K +1, and I would call it a cation. It's positively charged. That's the ion and the symbol for it. So that is one example of how ions, specifically cations, form. Metals are reactive because they lose their valence electrons. So like I showed you on the front, group 1, group 2, group 3A, or 13. So this would be your boron group, boron, aluminum. Those three are very easily going to lose valence electrons, have a +1 charge, +2 charge, +3 charge, and it shows you what happens. Transition metals. Transition metals are a little bit different. They typically can have, they're metal, so they're still going to be positive always. But sometimes they'll have a +2 charge, +3 charge. Silver can have a +1 charge. So it kind of depends on their electron arrangement. Oftentimes, if I'm not showing you the electron arrangement, look at your colored periodic table. And look at manganese, which is pretty much right in the middle of the table. Yep, letter Mn, symbol is Mn. How many valence electrons does Mn have? 2. So if I don't tell you any different, you're going to assume that manganese has a +2 charge from using your periodic table. If you look at silver, what is valence electrons for silver? 1. So you're going to assume that silver has a +1 charge unless I tell you differently and show you something differently. So that's how you'll use your periodic table if I don't tell you.
So if you don't tell us otherwise, then all the transition metals are cations?
Yes, and they will always be cations. But their charge can, so for example, iron can have a +2 charge or a +3 charge. It depends on which electrons, because it's in that D group, the electrons can move a little bit differently. So here if I'm looking at zinc, zinc is 4s2, 3d10, the D is full, it's going to leave those two. So in that case, zinc would have a +2 charge. And sometimes zinc can have a +3 charge.
How would it have +3?
What?
Like what makes it have a +3?
If it has a +3, it's probably going to lose the 2 S's and probably one of the D's also. It'll lose something in their D area or sublevel. Okay, negative ions. So now we're looking at group 5A, 6A, 7A, or 15, 16, 17. These are definitely going to be anions because group 15 is going to gain 3 electrons to get to 8, gain 2 electrons, gain 1 electron, and that's how you calculate that. The example that they have is chlorine. So chlorine has 7 valence electrons. So it has to gain 1 to get to 8. So that's going to give it a -1 charge. If I look at nitrogen, nitrogen has 1, 2, 3, 4, 5. It's going to have to gain 1, 2, 3. So it will have a -3 charge because it's going to gain 3 electrons. So anion is anything that's negatively charged. Figure shows chlorine. Table shows what it's losing, 1, 2, or 3. And some nonmetals, such as your group 4 or 14, that's not listed on here, some nonmetals can gain or lose, like carbon. Carbon can be positive, and it's called carbon. It can be negative, and then it'll be called carbide. So an anion is negative because it has gained electrons. And that is pretty much what you have for section 1. So not too bad.